Hello, my name is Autumn Kelly.
And my name is Roy Parrish.
And this is our slime project.
Yeah.
We used a number of materials, including shaving cream, kids' all-purpose glue, water, and contact. So the ingredients themselves weren't necessarily what made the viscous texture that we were looking for. It's just what is in the glue and in the shaving cream. So I'm going to talk about that for a second. First things first, the base, the glue, the most important ingredient, if you will, is made up of the mini vinyl polymers. Think of spaghetti chains, right? And we then added equal parts glue and contact solution, because contact solution has boric acid, connects the chains together very helpfully. This is very helpful in thickening up the slime. That's its main purpose, which remember later when we go over how we made our bouncy ball. So in addition to that, we added warm water, which helps to evenly spread out the boric acid to all of the polymer chains in the glue. And it affected the viscosity we noticed as we mixed our slime. Last but certainly not least, we added 4 whole pumps of shaving cream, which mostly just changed the porosity because of all the little air bubbles in that shaving cream. And those are our main ingredients. So now I'm going to cut to slime so you can see how exactly that turned out.
There were 2 parts to this experiment. The first part was to make a normal batch of slime. The second part was to make a bouncy ball out of the slime. In the first part, we had 4 questions that we could answer to describe the concepts that we were experimenting with and observing. The first question in part 1 was to hold the slime with both hands and pull it apart very quickly. How does it deform? Well, as you can see in the video, it deforms very quickly. It's more of a brittle reaction. It breaks apart as you pull it apart quickly. This is a lot different compared to part 2, or question 2, which is to hold the slime with both hands and pull it apart slowly. And it asks how it deforms then. And if you can see in the video, as I pull it apart slowly, it very slowly deforms. It doesn't just break apart like when I pulled it apart quickly. And this shows a bit of stress relaxation, which is basically where as I pull it apart, it slowly sinks down. And you can actually see this in question 3, which is to hold the slime with one hand and let gravity stretch it, or roll it into a ball and let it sit on a flat surface. What happens and what is it an example of? So in that question, the ball will slowly flatten out or fall down depending on if I'm holding it up or if it's just sitting on a flat surface. This is an example of creep, actually. As the slime is under a constant stress, which is the force of gravity, over time the strain reduces. And this is part of the time-dependent characteristics of a polymer. The last question for part 1, question 4, pull the slime apart and hold it at a fixed distance apart. The force required to keep it stretched should decrease. This is an example of stress relaxation. So basically, as you exert an amount of stress to pull the slime apart, over time, the amount of stress required to keep the slime pulled apart decreases. And this is another example of the characteristics of a time-dependent characteristics of a slime, or polymer.
As I went over the ingredient list earlier, we learned that boric acid combines the vinyl polymers in a slime together and makes it much more thick. So we assumed by adding more boric acid, we could make a thicker slime that would be more likely to be bouncy, and we were right. So we added significantly more boric acid and significantly less glue and water. We actually decided not to add any water because we were scared it would be too liquidy, and it ended up working out as shown in the video right now. And last but certainly not least, we added about 2 pumps of shaving cream to try to thicken it up a little bit. And even though we didn't have water, I think that is what helped spread the boric acid in the eye solution to the glue polymer chains.
And as with part 1 of the experiment, part 2 also had questions. It had 5 questions to be exact. The first question of which being, try bouncing your ball. How high does it get? Well, as you can see in the video that just played, or is playing now, the ball does bounce a lot more than the normal slime that we made before.
Absolutely.
And so maybe about 3 or 4 inches high, that's an extra. This third question, how did this change in recipe change the polymer structure? Well,
We haven't covered it.
we've pretty much already said, but basically with a reduced concentration of water, the different little polymer spaghetti strands, there's a lot more cross-linking, basically. There's a lot less distance in between the strands, and so it's a lot thicker, and so it's a lot less wiggle room for the different strands of the polymer. And so instead of being as viscous as a liquid, it becomes a lot more solid-like in behavior, and so it becomes a lot more elastic, which is pretty interesting. The fourth question is to roll your original slime into a ball and put it next to your new bouncy ball. How do their shapes change over time? Well, as you can see in the video demonstration we have here, the original batch of slime demonstrates a much more viscous reaction. It flattens out a lot faster than the bouncy ball. The bouncy ball kind of held its shape for the most part compared to the original slime, and this is due to a difference in structure, basically. You can also relate it to the Deborah numbers of the 2 different slimes. Deborah numbers basically work, the smaller the Deborah number, the more liquid-like it is, and the solids kind of go towards an infinite number for Deborah numbers. And you can tie that in because the original slime has a lot more of a viscous texture to it, so it has a much smaller Deborah number than the bouncy ball, which has a more solid, elastic behavior, so it has a much higher Deborah number. And the Deborah number can be used basically to tell you what you can expect characteristic-wise, like how viscous a substance is.